Okay, so I just want to go over just some examples from Delta Math so you can have an easier time doing these problems. All right, the function f of x is continuous on its domain from -9 to 9 and is plotted below such that a portion of the graph from 0 to 5 is hidden. So basically, they're telling you this is a continuous function, but they're covering up part of the graph so you can't see the full thing. Given that f of 0 is 2 and f of 5 is -2, right? What conclusions can be drawn based on the intermediate value theorem? Okay, so first it says, since function f is continuous, not necessarily continuous, or not continuous. Well, he told us in the problem that it is continuous. On its domain, the intermediate value theorem, since it's continuous, we can apply intermediate value theorem. Okay, so therefore, let's see, it's at any value k, there exists a c such that f of c is k. So just to be clear, f of c, so that c is the x, and f of c equals k, so k is the y. So for any k value, we're talking about the y value. So the y values are going from -2 to 0, because that was, no, sorry, -2 to 2. -2 to 2. Again, smallest y value to the biggest y value. There exists a c between the x values, so 0 and 5, such that f of c is k, right? So for every y value between -2 and 2, there's some value, c, that its y value is between -2 and 2. Okay, so based on that, must there exist a value between 0 and 5 such that f of c is -4? Well, -4 isn't between -2 and 2, so that's not guaranteed. So there may exist, but there may not exist. Right? We have no way of knowing for sure. Does the function go down to -4? It might, but we only are guaranteed that it goes between 2 and -2. Okay, so let's make sure I got that right. Great. Let's look at another one. Okay, so this function has a domain, it's plotted, a portion is hidden, etc. They give us the same, f of 1 is -5 and f of 2 is 5. What conclusions can be drawn? Well, they never state that it's continuous, so it's not necessarily continuous. Therefore, the intermediate value theorem cannot be applied. Therefore, there may exist, may not exist. We can't guarantee anything. A value c in the interval from, what's our x intervals? -1 and 2. Such that f of c is -3. It's possible that but we just can't guarantee it. All right. If you want, I'll do one more. If you've got this, feel free to close me out. We move on. This is similar. It doesn't say that it's continuous, so let's try a new problem. Okay, this one is continuous. Tells us it's continuous, so we can apply the intermediate value theorem. Okay. Given that f of 2 is -3 and f of 5 is -5. So our y values are going from -5 to -3, the lowest to highest. And their x values are between -2 and 5. Must there exist a value between -2 and 5 such that f of c is -6? Here's another one that's out of our range, so could be. If it was in the range from -5 to -3, then we would guarantee that it is. Okay. All right. All right, give it a shot. If not, you can always watch the help videos that they have on Delta Math as well. All right.